Welcome to the video lesson on rational expressions. This video will explain what a rational expression is. It will explain how to state restricted values, also called restrictions, and also it will explain how to reduce rational expressions to their lowest terms. First up, what is a rational expression? The definition is that a rational expression is any expression that can be written as p over q, where both p and q are polynomials, and specifically where q is not equal to 0. We can't divide by 0 in math because it's undefined. So examples of rational expressions could be, this is a polynomial divided by a polynomial, and as long as we don't allow 4x minus 5 to equal 0, then that would be allowed. This is another expression, even if those are monomials, and even if they're constants, both of these, or all three of these, are considered rational expressions on their own. So it's some polynomial over some polynomial. So that whole thing with the not dividing by 0, in math we say that an expression is undefined when the denominator, the part on the bottom, is equal to 0. The numerator can be 0, because you can do 0 divided by anything. You just can't do anything divided by 0. And that's what allows for what are called restricted values. So how do you find a restricted value? Well, if your denominator is not already factored, you have to factor it. And this is one of the reasons that factoring is so important. The next step is to make the equations or set up equations by setting each individual factor not equal to 0. And then you may have to do algebra as if it was an equal sign, but we're going to keep the not equals. And that will allow us to find what values would make the denominator 0, and we disallow them. We make sure that we don't include those as allowed values. So those values are restricted, and it means that they are not allowed as part of the domain of a function. That terminology is sometimes used, but most of the time we'll say that those are just restricted values or restrictions on the variable. So in this case here, this question asks you to determine the restrictions for the value of x. And here's how we deal with that. We take all of the factors of the denominator. And in this case, it's a monomial, so there's just one factor. So we just skip to the next step where we set that not equal to 0. And if I wanted to isolate the variable there, what I would have to do is divide both sides by 2, and 0 divided by 2 is 0. So what that means is that x can't equal 0. It means that in this rational expression, x could be anything in the universe except 0. And the reason why is that when x is 0, it makes the denominator 0, and that's not allowed. So our only restricted value here is that x cannot equal 0. In a case like this, if the denominator is factorable, and here it is, I have to factor it first. And the reason why is because it makes it much easier to figure out what values of the variable would make the denominator 0. Here you might be able to guess one, or maybe more, values that could work. But as a general rule of thumb, it makes things much easier to factor. So in this denominator, there are two terms. The first thing you would do is look for a GCF, and there is one. So when I factor that, if I remove the GCF, this is how it factors. And now, neither one of those factors is factorable on its own, so that's the most factored that gets. My next step is to take each factor, even if the factor is just a single term, and set it not equal to 0. So my two possibilities here, if this denominator were to be 0, either x would equal 0 or x minus 4 would equal 0. And I'll solve those with not equals because I want to make sure that x is not equal to 0. So option 1 is that this on its own, that's already isolated. It means that x can't be 0. And in this case, to isolate the variable, I'd have to add 4 to both sides or move this negative 4 to the other side. And that's what my restriction is. So in this case, I have two restricted values. Frequently, they can be listed this way. They could be listed with squiggly brackets, set brackets. But what the important idea is that in this case, it means x cannot be 0 and it cannot be 4. And if you went back to the original and tried to plug in either one of those, they would both make the denominator equal to 0. So here, if you want to pause and give it a try, I encourage you to do that. I'll go through the answer in just a minute. But The first step is to factor the denominator. So again, if you want to pause it and try that, go ahead. I'll show the answer now. When you factor this denominator, it factors as x minus 2 and x minus 1. If I set each one of the factors not equal to 0, you can pause it if you like and see if you can come up with the restricted values. Here, those restricted values are that x can't equal 2 and x can't equal 1. And if you went back to the original and tried it, if you tried plugging in 1 or if you tried plugging in 2, either one of those values would make the denominator equal to 0. So those are the two restricted values. It means that x cannot be 1, it cannot be 2. Typically, those will be listed in squiggly set brackets. And if you want to try this one as well on your own, I encourage you to pause, give it a try on a piece of scrap paper. I'll show you the answer. When I factor the denominator, it factors as 3x minus 5 and x plus 1. And when I take each one of those factors separately and set it not equal to 0, I have to isolate the variable. So in this case, I'll actually have two steps. I'll have to bring the negative 5 to the other side and then divide by 3. And that means that this restricted value is that x can't be 5 over 3. And it's all right if my restricted value is a fraction. In this case, when I isolate my variable, I get negative 1, and it's okay if my restricted value is negative. So those are my two restricted values here. Note that x not equal to 0 on its own is not necessarily a restricted value, only if there had been a factor outside that was x all by itself. So that's how you find the restricted values in the denominator, and there's a separate video that will show you how to reduce rational expressions to their simplest terms.